In Chapter 11, Section 1, we're going to focus on circumference and arc length. In the previous chapter, Chapter 10, we focused a lot on the degree measure of the arc, but we never really talked about how long the arc was, or the arcs were. And so in this section, we're going to talk about arc length in addition to arc degree measure. So first of all, we want to kind of review what the circumference of a circle is. The circumference of a circle is basically the entire distance around the circle. So how far would you have to travel, or whatever, how long is the distance around the circle? Now, if we're dealing with a particular arc measure within it, then what we're trying to find is the length of that arc, that piece of the circumference. So notice that the arc that we're looking for is a piece of the entire circumference of the circle. So the circumference of a circle has a formula, and it's either 2 times pi times r, or it's the diameter times pi. Remember that the radius is half of the diameter. In other words, it's from the center to the end. The other side is the radius. So notice that the entire length of the diameter is 2 radiuses, and that's where the 2 and the r come, okay? So if I'm trying to figure out the arc length, right, remember that, again, the arc length is a portion of the circumference of a circle. If we know the measure of the arc in degrees, we can utilize that to help us find what the arc length is. So what's going to happen is our arc length, or let's start this way. Our arc degree, whatever that measure is going to be a certain portion of the entire degree of a circle, which we know is 360. So that's going to create a ratio for you. Let's just pretend that this was a 90-degree angle there. Well, the arc degree over 360 is 1/4. And what we're saying is that this quarter is a quarter of the total degree of the circle. Well, what's interesting is this arc length then is going to also be a quarter of the entire length of the circle. And so notice that I could do something like this. I could create a ratio. I could say the arc degree over 360 is going to be the same ratio as the arc length over the entire circumference. And that's a valid ratio. So if you tell me the arc degree, 360 is always 360, and you tell me the arc length, guess what? I can find the circumference. Or if you give me the circumference, I can find the arc length. I can use proportional math to find the missing piece. So this is one way that we do it. When I was taught in school, I was taught using the proportion, and that's what this method here is, okay? Saying that the ratio of the arc length to the total circumference is going to be the same as the arc degree to 360. The second way we can solve this is using this formula. Now, a lot of people seem to like that formula. I'm not a fan of it. I like using the proportions, but again, the formula works as well. And what it basically says is the arc length, okay, how long arc AB is, for example, in this picture, is going to equal the ratio of the arc measure, the arc degree over 360, so let me just write it as arc degree, right, times the circumference. So if you want to memorize this, you can. So again, it's the arc degree over 360 times the circumference of the circle, and that's going to give you the arc length, okay? Now, again, if you sort of look at the proportion we created, if I was to do the math here, notice that I would get arc degree, right, times the circumference, right, equals 360 times the arc length. And if I basically divide this side by 360, 360 and divide this side by 360, notice that I'm going to get the arc length equals arc degree times circumference over 360. Well, again, notice this is arc degree times circumference over 360. So it's the same as the formula, it's just in a proportion form. So now that we know this, let's kind of apply it. And you can figure out for yourself whether you like doing the proportion or whether you like doing the formula. So here we go. It says find the circumference of a circle. So here's just some basic circumference problems. It says the diameter equals 5. It says leave your answer in terms of pi and use 3.14 for pi. So leaving it in terms of pi and using 3.14 is kind of confusing, but I think what they want us to do is they want us to do both. So if the diameter is 5, I know that my circumference is, like I said, it's 2 pi r, or my circumference is diameter times pi. Since they gave me the diameter here, then I'll use the 5 pi. So I know that my circumference is 5 pi, right? That's an exact answer. And if they want the second value for it, it's going to be c equals 5 times 3.14 for pi. Now it's important that it tells you what to use for pi, because again, you could leave your answer with pi. You could use 3.14, which means the answer is approximately 15.7 inches. That would be my circumference. Or I might actually use pi in my calculator, which would give me a different answer. And so you always want to read and see what do they want and how do they want you to do it. Notice that here I did equal, and in this one I did this squiggly lines, which means approximately equal. And it's because 3.14 is not exact. It's a rounded version of pi, and so I have to kind of show that my answer is not exactly 15.7. Leaving the answer in pi is actually exact, and so that, to me, is the better way to write it. Okay, so then we go to B, and it says find the radius of a circle with a circumference of 17 pi. So again, I know that my circumference is 2 pi r, or my circumference is diameter times pi. And in this one, since I'm looking for r, I'm going to use this formula. So I've got 2, I've got pi, and I've got r, and then it tells me that my circumference is 17 pi. So right now, if I'm solving for r, I need to isolate r. And if I divide both sides by 2 pi, I'm going to isolate r, because the 2 and the pi's will cancel. And then on the other side, my pi's will cancel, and I'm gonna get that r is 17 over 2, right? Or 8.5. And so I know that my radius is 8.5 inches. We keep going, we keep reading the problems. Find the diameter of a circle with a circumference of 16 feet. Use a calculator and round to the nearest hundredth. Now here, notice it says use a calculator, round to the nearest hundredth, that matters, but basically they didn't tell you what to use for pi. So in this case, they're gonna want you to use pi on the calculator. So again, circumference is diameter times pi, or circumference equals 2 pi r. Since we're looking for the diameter, we're gonna use this one. So if the circumference is 16 feet and its diameter times pi, then what's the diameter? Well, I'm gonna divide both sides by pi. So in this problem, my diameter equals 16 divided by pi. And so when I do that on my calculator, I'm going to get this, I'm going to do, right, 5.092958, blah, 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 right? So I get all these numbers. Well, remember, I want diameter is approximately equal, and I'm rounding to the nearest hundredth. Since this is the hundredth, I look at the number to the right of it. If it's between 0 and 4, then that number stays the same. If it's between 5 and 9, then that number would have gone up. So it did not, it's 5.09, and I'm able to, and it's feet. So that's how I find my diameter. When I go to B, it says a car tire has a diameter of 28 inches. So there's my diameter. How many revolutions does the tire make while traveling 500 feet? Use a calculator and round to the nearest tenth. So again, I got to round to the nearest tenth, and by using a calculator, that means it's going to want me to use pi in this. Now, one thing that's interesting is you have to realize that when a tire makes or something makes a complete revolution, the length it travels in that revolution is the circumference of a circle. Every time that I make a lap around a circle, let's say a tire, right, one revolution is one circumference. So to know if the tire has a diameter of 28 inches, first let me figure out what would one revolution of the tire mean. In other words, what is the circumference of that tire? So I know I'm going to use the diameter times pi formula. So the circumference is going to be 28 pi. And again, just to have an idea, right, I want to kind of understand, I could plug in here pi in my calculator and multiply it. And when I do that, I'm going to get 28 pi. I'm going to get something like 87.96. So it's approximately 88 inches per revolution. However, I could work with this rounded figure, or I could just wait and round at the very, very end. So what I could do is I could say, okay, if I'm traveling 500 feet, right, notice that my diameter is in inches. The first thing I'm going to do is I'm going to say, okay, 500 feet equals, right, 500 times 12 inches, right? So if I do 500 times 12, 500 feet equals 6,000 inches, all right? And I know that each revolution that I go, every time I go one circumference or one revolution, I go 28 pi inches. I know that if I divide 6,000 by 28 pi, that's going to give me the number of revolutions that I would need. So instead of kind of floating around with this rounded number, I'm just going to do 6,000 divided by, and then in parentheses on the denominator, I'll do 28 times pi, and I'll get my answer. And when I do the math, I'll get one long number, 68.209. And so that's going to be the number of revolutions, 68.2. And it says round to the nearest tenth. So it's going to be 68.2 revolutions. So for my tire with a diameter of 28 inches to move, right, 500 feet, which is 6,000 inches, I've got to do 68.2 revolutions to get to that number, okay? So what I could have done is I changed my my distance that I was traveling from feet to inches to match the diameter. I could have also converted the diameter to feet, and then I could have solved the problem that way. I just thought it was easier to go from inches to feet. All right, so now we're going to do some of the ones where we talked about with the proportions. And so again, we're going to look at A, and we're going to kind of figure out what we've got going here. Notice that the central angle is 75 degrees. That means that the arc degree is 75 degrees. So the first thing is I want to create a ratio of that arc degree to the entire, or central angle, either one, to the total degree of the circle, which is 360. Now, I can simplify this ratio a little bit if I wanted to. I could, for example, divide, for example, everything by 5 to make it smaller. But because I'm using a calculator, I don't really have to work that hard. I can just leave it at 75 over 360. And now, again, remember that I'm looking for arc length PQ, which is this piece. And it's going to be a ratio over the entire circumference. And the circumference is diameter times pi, or pi r, or 2 pi r. Notice the diameter is 9. So I know that the circumference of this circle is 9 pi. And so now it says keep your answers in terms of pi, so I don't have to multiply any further. But I can now figure out arc length PQ by doing cross products. I know that 360 times arc length PQ is going to equal 75 times 9 pi. When I do the math, I'm going to get 360 times PQ, again, arc length PQ, equals 675 pi. And if I divide both sides by 360, I'm going to get my final answer in terms of pi. So arc length PQ is going to equal 675 divided by 360 is 1.875 pi. So that is how long that PQ is. Now I know that's not super satisfying, right, to know in terms of pi, because it's kind of weird. You really don't know exactly how long, but this is the length, okay? Obviously pi is, let's just pretend I was multiplying. It'd be about 5.89 units when I multiply everything out by pi. But again, that's how we solve it using proportions. Now, if you wanted to solve it using the formula, you could do that as well. Remember, the formula is the arc length of PQ is going to be the ratio of the arc degree over 360 times the circumference, which was 9 pi. And again, this formula would give you the same answer, okay? You would multiply it out and you would get 1.875 pi as the arc length. So that's how long it is from Q to P. Let's do a second one, and we'll do both methods again. So again, the second one says B, the circumference of circle N is what we're looking for. Okay, so we're looking for circumference. Notice that they gave us this arc length here. They said, or basically they gave us this angle here was 270. So let's think about it. Let's think about it a little bit more this way. That length is 60 pi meters here. So we're like, okay, 270 degrees over 360, okay, is the ratio of this angle here to the entire circle. And that's going to equal the same ratio of the arc length of that same piece over the circumference of the entire circle. So that would be my setup if I set this up using ratios. So again, I would do, and again, 270 over 360. This one I could simplify a little bit just for purposes, because I know this is 3/4. And that's just a little bit easier, right? So if I did cross products, I would get 4 times 60 pi equals 3 times the circumference. So 240 pi equals 3 times the circumference. And if I divide everything by 3, I'm going to get 80 pi equals the circumference. So the circumference of circle N is 80 pi. Okay? And that's how I would solve it this way. If I wanted to do the other method, it would be, again, the arc length, which in this case, this big arc has a length of 60 pi, and the arc length is equal to the ratio of the arc degree over 360 times the circumference. So in this case, I'd have 60 pi equals, again, 270 over 360 simplifies to 3/4 C, and if I was solving for C, I could multiply both sides by the reciprocal. That would isolate C for me, right? So I would get C equals 4/3 times 60 pi. Well, that equals 240 pi over 3, which simplifies to 80 pi. And notice you got the same answer. So again, it's just which one you like better. I personally prefer the ratios, and we're going to learn about areas of sectors as well in the next section, and I just feel like the ratios make sense. So that's pretty much the gist of it. Now we're just going to work on more problems of the same. So here, for example, find the indicated measure, use a calculator, and round to the nearest tenth. So when they say use a calculator, then they want you to use pi and rounding to the nearest tenth. So again, they want to know the circumference of circle N. Well, once again, we know ratio-wise, we're going to do 270 over 360 equals the arc length over the entire circumference. So once again, this is 3/4, and we're just going to do the math. It's going to be 4 times 61.26 equals 3c. So I know if I divide it by 3, I'm going to get the answer. So I'm going to use my calculator to do the math. And when I do the math, I get 81.68. And that is the circumference. So it's meters. And that's the answer. I'm sorry, it told me to round to the nearest tenth. So it's going to be 81.7 meters is my circumference. That's the perfect answer. And again, if I did my ratio, my formula, it would be the same way that we did it the last time. I'll do this second one here. I'll do this using the formula. So notice here it says, what is the radius of circle G? So again, we're looking for the radius, but we know that we have a way that we can set this up. So let's do proportions first. I know the 150 degrees over 360 is my ratio. I know that the length of this arc is going to go over the entire circumference. And since we're looking for the radius, I'm going to write the circumference as 2 pi r down here, because that's going to be easier to kind of solve for r. If they were looking for the diameter, I would use diameter times pi, and if they're just looking for the circumference, I would just put c. So again, I'm going to use my cross products here. So 360 times 10.5 equals 150 times 2 pi r. So let's do the math and kind of simplify that left side. So the left side is 3,780, and the right side is going to be 150 times 2, that's 300 pi r. Now remember that what we're solving for is r, and so if I divide both sides by 300 pi, I'm going to get my final calculation, right? My radius is going to equal whatever that is, and so I'll do that on my calculator. I'll do 3,780 divided by, and then in parentheses underneath, I'll put 300 times pi, and parentheses equals. And I get 4.01. We're talking about feet here. So I know my radius is about 4 feet. They want it to the nearest tenth, so it's going to be 4.0 feet, or just 4 feet. And so that's how you do it. So again, you got to make sure that you know how to use your calculator to get the right answers. The last thing we're going to do in this section, and it kind of is thrown in here at the end, but basically we're learning, we're going to be utilizing a different kind of unit of measure for angle size, and it's called radians. It's also another way of measuring arc degrees as well. So right now we've been doing everything in degrees, which is what you're used to, where 1 revolution is 360 degrees and things like that. Well, a radian is another unit of measure for angles. And so it's an alternative. Remember, I always tell you to make sure your calculator is in degrees and not radians and stuff like that. So how does a radian compare to, let's say, a degree? Well, if we are, for example, dealing with a circle, right? We have our circle. Let me just do this right. You have your circle here, and your radius is 1, right? If I do 1 complete revolution, right, if r equals 1, but if I start here and I do 1 complete revolution, we all know that 1 revolution is 360 degrees, sorry. So if I did radians, notice that if my radius is 1, I know my circumference is 2 pi r, and if r is 1, then my circumference would be 2 pi. So in what's called a unit circle, or the most basic with a radius of 1, we recognize that 1 complete revolution, okay, is 360 degrees, but it's also 2 pi in radians, okay? So I know that's kind of a little bit strange to kind of do it, but we just recognize that 360 degrees is the same as 2 pi radians, okay? So once we know that 2 pi is 360 degrees, well, what do you think 1 pi would be? What's half of 2 pi? Half of 2 pi is 1 pi, and half of 360 is 180. So we know that pi radians is equal to 180 degrees. And so again, this is just kind of something you're going to have to memorize. So if we're given something, let's say in degrees, like we're given something and we're saying, okay, well, 270 degrees is how many radians? Well, we would multiply it by what fraction with this relationship. In other words, if what we want is radians, we'll put the radians at the top, and what we want to get rid of, the degree, will go at the bottom. And so what happens is your degrees will kind of cancel, and you'll be like, okay, 270 pi over 180. When I simplify that and I do my math, I'm going to get 3 over 2 pi. Well, 270 degrees is equal to 3 over 2 pi radians, or 3 pi over 2 radians. And so, again, we're going to get into this a lot when you get into Algebra 2, but you just want to understand how to convert from one to the other. So what if I want to go from 3 pi over 2 radians back to degrees? Well, again, I'm going to put degrees up top, and I'll put pi at the bottom. My fraction that I'm going to use every time is going to have 180 and pi. What I want to get rid of is going to be in the denominator spot. What I want to keep is going to be in the numerator spot. And then I multiply. So I'll cancel my pi's. 3 times 180 is 540 over 2. And 540 over 2 is 270 degrees. And so that's how I go from the one to the other. And the ratio that I can use the 180 over pi and the pi over 180, or I could use 2 pi over 360 and 360 over 2 pi. Since this is unsimplified, we often use the simplified version, but you can use whichever one you want. So if I ask you to convert, again, 2 radians, we're in degrees, 15 degrees. I know my final answer is going to be in radians. So I know I have to use pi and 180. Well, if I want to get rid of degrees, then I got to put it at the bottom and pi at the top. So it's going to be 15 pi over 180 radians. And I can kind of simplify and do the math a little bit there. I can either just simplify the fraction. I can do like I can actually do it, divide it and do, okay, that's 0.1875 pi radians, but we don't really do that. How we simplify radians is we just divide out and simplify the fraction. So 15 goes into both of these. 15 goes into 15 one time, so we're left with pi, and 15 goes into 180 2 times. So it's pi over 12 radians, and that's our answer. And then the last one here, we have convert these radians to degrees. So again, I know I'm going to do 180 and pi. What I want to get rid of goes at the bottom. The degrees go at the top. And so I can cancel out, and I can even simplify before I multiply just to make it a little easier. 3 and 180 have 3 in common, right? So I'm going to be left with 4 times 60, or 240 degrees. So 4 pi over 3 radians is 240 degrees. And again, we'll get into more uses with radians, but just understand the process. Once you understand how to do it, it's always 180 and pi. It's just what you want to keep is on top, what you want to get rid of goes at the bottom, and the rest I think is pretty self-explanatory.